Hello, I'm Andre Loy, and I am the International Director of Regeneration International. We are an international NGO that's involved in regenerating agriculture, regenerating our climate, and regenerating our cultures and our democracy. I am also the author of The Myths of Safe Pesticides and Poisoning Our Children. Previously, I was the president of IFOAM Organics International. I'm also an organic farmer. I grow tropical organic fruits such as lychees, rambutan, mangosteens, durian. What I'd like to firstly say is I wish I could be in Taiwan at the moment. I really love your country. You have a magnificent country, one of the most beautiful on this planet. And hopefully when this is over, I can come back, and next time we do this conference, I'll be with you, and I really look forward to it. What I really want to talk about today is probably the most important of the Sustainable Development Goals, because it is affecting all of us. Doesn't matter where we live on the planet, we will be affected by climate change. In fact, it is a climate crisis. It's a very serious climate crisis. Only a few days ago, on April 3 in Manilao in Hawaii, they recorded 420 parts per million of carbon dioxide. Now, this is a new record. The last time we can go back to something close to it was between 3 and 3.5 million years ago, when there was 380 parts per million. Now, according to papers published in the peer-reviewed journal Nature, the world was between 5 degrees to 16 degrees warmer there then. And sea levels were 20 to 30 meters higher. That's at 380. We are already at 420 parts per million. And our CO2 levels are increasing between 2 parts per million and 3.3 parts per million per year. It's actually getting worse despite the Paris agreements. And if the world meets the Paris target of net zero emissions by 2050, we will be close to 500 parts per million. What we are looking at, if we meet the Paris target, is crossing multiple tipping points of catastrophic climate change. It's important to remember that the carbon dioxide we have in the atmosphere now will remain there for hundreds of years. And so what we have is actually the cumulative impact of our current emissions. And this extra heat becomes energy that fuels our climate. The most important way to think about this is the amount of energy it takes to heat up our planet, our atmosphere, and our oceans by 1 degree. And that's the equivalent of millions and millions of atomic bombs worth of energy every year. And I'm using this violent metaphor to explain what is happening to our crisis, to our climate, because all this extra energy is violently fueling our climate. It makes weather events so much more extreme. So for instance, last year, in your part of the Pacific, you had one of the worst hurricane seasons on record. Not just the amount of the hurricanes, but the size of them. It was the same in the Atlantic with the Caribbean one. We're seeing droughts, fires, floods, crop failures. They're becoming more intense and more frequent, and they're only going to get worse. I'm going to talk about the sea level rises. If we want to talk about 20 to 30 meter sea level rises, and this is what we will get, we will lose all the atoll islands in the Pacific, much of Bangladesh, the Netherlands, Denmark, coastal USA. You think about, what a 20 meter or 30 meter rise in sea level will do to Taipei or Kaohsiung, New York, New Orleans, Miami, London, Manila, Yokohama, Bangkok, Calcutta, Shanghai, Singapore. We are talking about causing a refugee crisis of hundreds of millions of people. And this is starting to happen now. So what we have to do is not just go to zero net emissions. If we meet the Paris target, it will be a disaster for the planet. We have to start taking carbon dioxide out of the atmosphere and returning the planet back to the levels that it was prior to the Industrial Revolution. We have to go to negative emissions, and we need to do it now. So let's talk about how we can do it. Well, soils are the greatest carbon sink after the oceans. We already have too much carbon dioxide in the oceans, and we're acidifying them. We're causing a problem, like we have too much carbon dioxide in the atmosphere. But the research shows that the soils hold almost 3 times the amount of carbon as all the carbon stored in forests and in the atmosphere. So the most logical thing we can do is take the carbon dioxide out of the atmosphere and put it back into the soil where it is needed. We have to end fossil fuels, and we have to adopt renewable energies. That's not non-negotiable. But just stopping polluting is not enough to stop catastrophic climate change, because the legacy emissions we have now will be a disaster, because given the past history, we're talking of going up to at least 5 degrees in centigrade, so a minimum of 5 degrees centigrade, and we're talking about ocean levels going up between 20 to 30 meters. We have to start drawing down carbon dioxide just to stabilize where we are. So, for instance, we need to draw down around 25 gigatons of carbon dioxide per year just to stabilize our levels at around 417. But we should really further scale it up so we can start reducing it. And the good news is there is a global platform to do it. It was launched in Paris as part of the United Nations Paris meeting, and it's called the 4 for 1,000 initiative. And when I was president of IFOAM Organics International, I was very proud to be signature number 7 on this document. And the United Nations recognizes this initiative by the French government as part of the Lima Paris Accord of the Paris Climate Change Agreement. Now, at the moment, 32 countries have signed on, many regions, many United Nations organizations, and hundreds of non-government organizations have signed on. And this is part of the process of changing farming from being one of the major emitters, a major problem, to becoming a major solution. Because what we will do is take carbon dioxide out of the atmosphere and use farming to store it into the soil as soil organic matter. So how do we do this? It's very simple. We use the most efficient solar energy collectors on the planet. They're called leaves, and we use photosynthesis. So solar energy combines carbon dioxide and water in the leaves of plants, and it produces glucose, which is the basic molecule of life. And glucose is what feeds most food systems. This is the chemical equation. We take 6 molecules of carbon dioxide, 6 molecules of water, use the solar energy that's captured by the leaves. We make a molecule of glucose and a byproduct of oxygen. In fact, most of the oxygen that we breathe in our atmosphere comes through this process of photosynthesis. When we look at a plant, between 95%, 98% of what we see, its biomass, comes from water and carbon dioxide through photosynthesis. Sorry, we went the wrong way. Plants then use glucose to synthesize sugars, carbohydrates, hydrocarbons, amino acids, all the compounds that we need for life. I'm having trouble with, here we go. What I want to show here, which is really important, go back again. What I want to show here that is very important is that plants feed through their leaves. Everybody thinks that plants feed through their roots, but 95% of what you see in a plant there comes from photosynthesis, from the water and the glucose that's then combined in the leaves using solar energy to make cellulose, to make sugars, starches, proteins. And this is what the plant uses to build. So the plants feed their roots and they grow their roots through photosynthesis. When we cut the leaves, they don't have enough products of photosynthesis to feed their roots. They basically have to lose roots to stay in balance, because if they don't have enough to feed their roots and they lose all their roots, they die. So what they do is they shed off their excess roots so they're in balance, feed enough, and then they can grow again. But also while plants are growing, what is really important there, from their roots, they exude around 30% of these compounds of photosynthesis, these molecules of life, into the soil to feed the soil microbiome. So what I want to show here is that when we cut the plant leaves and you see all that organic material from the roots going into the soil, that's an enormous amount of organic compounds, organic carbon compounds, organic matter. We can use this now as for new forms of agriculture, where instead of spraying them out and poisoning them, by modifying how we manage them, we can get them to shed this material, this organic material, into the soil, to put this organic matter, this organic carbon into the soil. So these are some of the new ways of doing it now. And there's a lot of new methods being developed that are getting substantial amounts of carbon dioxide out of the atmosphere into the leaves of plants and then via the roots into the ground. So this is a method in Australia where they grow annual crops in perennial pastures. Instead of poisoning them and killing them, they just open it up and they plant what we call the cover crop in the pasture and grow the extra pasture. This particular system, the farmer has been paid for capturing carbon dioxide out of the atmosphere and putting it into the soil. And 2 years ago, he got paid for capturing 11.2 metric tons per hectare and putting that into the soil. Last year, he got paid for increasing it to 13 metric tons per hectare. And this has been verified by the Australian government. If we were to extrapolate this system globally across agricultural lands, we could sequester 55 gigatons of carbon dioxide per year. Now, this is very significant because remember, if we can capture 25 gigatons, we can stabilize. If we can capture more than 25, we can start reversing climate change. In other words, we're going into negative emissions. We're drawing it out of the atmosphere, which is what we have to do. So I want to show you this as proof of concept that he's the first farmer in the world to be paid by a government for taking carbon dioxide out of the atmosphere through agriculture and putting it into the soil. And there are many more examples. This is an example of using a specially aerated compost. It can be done at any scale, from industrial scale to backyard scale. I wanted to show the backyard scale because in most of the world, most farmers only have a few hectares. So it can be done at this scale. Their trials showed that by applying this compost to agricultural systems, they could be sequestering 37 metric tons of carbon dioxide per hectare per year. If we were to extrapolate that by agricultural lands, that's 184 gigatons of carbon dioxide that we could take out of the atmosphere per year. Not only that, but these systems are increasing yields. I think this is the really important thing. The one I showed you before, their stocking density for animals is double the previous system. In this case, we're seeing large increases in yields without the use of toxic chemicals, without the use of synthetic pesticides and synthetic fertilizers. This is, I think, the really important thing I want to get across is that instead of using tons of nitrogen per hectare, they don't have to use any. It saves money and the yields are substantially higher. This is another example, and this is in California, but it's on, just under a hectare, but it can be applied to most of the world because most of the world's farmers are 2 hectares or less. And what they're doing is what we call no-till, no-kill. Instead of plowing out and spraying, what they are doing here is growing in compost and mulch. They increase their soil organic matter from 2.4% to close to 8% in 6 years. And this is verified by Chico State University in the USA. So this is good quality data. They, really important about this one, they massively increase their output and their production per hectare, or in the US per acre. And they're earning something like $400,000 for the hectare, and they employ 8 people. This is an excellent model for smallholder farmers to increase their output and their earnings per hectare. When it comes to climate change, if we were to extrapolate this across arable and permanent croplands, it would sequester 179 gigatons of carbon dioxide per year. Then the other really important form of regenerative agriculture is to do with grazing, because 68% of our designated agricultural lands are rangelands, and most of them are highly degraded. With the new forms of regenerative and holistic grazing, we can restore these lands, increase their biodiversity, their carrying capacity, their water infiltration, and we can sequester carbon dioxide. This is an example of one peer-reviewed scientific study looking at degraded lands, arid lands in Arizona, and they sequestered around 30 metric tons of carbon dioxide per hectare per year. Now, if we would extrapolate this across the world's rangelands, these systems would sequester just under 100 gigatons of carbon dioxide per year. So what I want to say here is that this is actually very, very good news, because we don't have to transition all of agriculture. We just have to transition a small percentage of agriculture to these best practices, and we can significantly reverse climate change. So, for instance, if we could just get 10% of agricultural lands to start using beam, the beam compost, we could sequester around 18.5 gigatons of carbon dioxide per year. We get 10% of smallholder farms across the world to use the Singing Frog Farm's no-kill, no-till systems, we could sequester around 18 gigatons. And then if we could get 10% of the grasslands under regenerative grazing, that would be around 10 gigatons of carbon dioxide. And this would result in around 46 gigatons of carbon dioxide being sequestered per year, which is almost double what we need to do. So what I want to show here is that just with some examples of best practices, and we have lots of them, and just getting a realistic target of trying to just scale up to 10% of agriculture, we can reverse climate change. This is very doable. What is really important to put across here is that we don't have to invent anything new. These systems exist. They're out there now. They have good science, evidence-based science to show that they work. All we need to do is scale them up. We don't need to invest hundreds of millions of dollars on geoengineering and other unproven systems. We just need education and training. And the good thing about most of these systems is that they have been developed by farmers, innovative farmers. And we know that once we start scaling these out, there'll be further innovation to improve it, particularly when we can get scientists and innovative farmers working together. We could even get better systems. This is a really wonderful story. We could get the world back to pre-industrial CO2 levels. And just as importantly, we can produce higher yields of healthy food with no toxic chemicals. And they're shovel-ready solutions. So thank you very much. And I hope you will give this serious thought. Thank you.